1976. It was the year a spacecraft successfully landed on Mars and performed this mission for the first time ever. This was the Viking mission. This was a mission from NASA. It had the goal to search for alien life on Mars for the first time ever. It was also the first time we had images, color images, and also black and white images from the red planet. And so this mission, the Viking mission, had many firsts. But definitely, it was not the first time that scientists detected alien life on the red planet. And this was highly disappointing. And so you may be asking, okay, we didn't detect in the 70s any alien life, so why do we keep investing time and money on space exploration, and in particular to go to Mars? So there was a problem, well actually two problems in this mission, and we only found out that later on. So problem number one, we're looking on the wrong location. On the Viking mission, we're actually looking on the surface for signs of life. And we now know that the surface of Mars is not a very friendly place to find any life forms, if they exist. And so that's why future missions to Mars, they're drilling and they're looking on the subsurface of the red planet. Problem number two, and that's the major problem, technology. In the 70s, and in particular in 1976, technology was not state-of-the-art. So what we know now is that if we had a gram of soil and we spiked it with lots and lots of cells and microorganisms, the technology on board the Viking mission wouldn't be able to detect any of that. So, luckily for us, technology has evolved. And so, scientists did not give up in the 70s, and they continued to go to Mars. We had many missions orbiting the red planet. We had many missions on the surface of Mars. You can see some of them here. And luckily, we carried on. And yes, we're yet to discover alien life on Mars. And actually, we're yet to discover alien life anywhere in the solar system or the universe. But the good thing is that we're continuing to invest in space exploration. We're continuing to search for alien life, and we're continuing, above all, to develop technology. And so we continue, as I said, with many, many space missions throughout the solar system, trying to find alien life. How do we do that? We do that by developing technology that allow us to detect alien life either on Mars or the icy moons of Jupiter and Saturn, or even to expand the human presence beyond the sphere of the Earth. So, for example, going to the International Space Station. This is one of the astronauts that does the spacewalk when outside of the International Space Station. Above all, we want to know, why do we do this? What do we profit with this? Well, there are many things. First of all, we have economic return. I'm going to show you that in a minute. And the second thing is actually we're producing services and products that actually benefit and improve the quality of life here on Earth. And so there is a study that actually shows and clearly shows that for every dollar that the American government invests in NASA, and in particular in space exploration, there is a return on the economy between $7 to $14. That's huge. And so how do we do that? Well, actually, we gain and we get that economic return by spin-off technology. And spin-off technology could be services or products that we develop that have a value, that also generates jobs, and at the same time, we can even save lives. So there are three ways that spin-off technology in the space industry can occur. So first one, NASA or any space agency, it doesn't have to be NASA, it could be the European Space Agency or the Japanese Space Agency, any space agency. They develop a product and then they patent that product. And then later on, a company outside buys that product, buys the license. So that's way number one. Way number two, we have the space working together with the company and developing a product that already exists, so announcing that product. And way number 3, the space agency doesn't have a clue, they need a certain product. So what they're going to do, they're going to contact some company and say, look, I need this product, so you're going to develop that for us. And then many years later, that company can use that development to actually sell that equipment. Let me give you an example. So we are in 1961, NASA wants to go to the moon, and as you can imagine, they don't want just to go to the moon. They want to go to the moon, but they want to collect rocks. And in order to collect rocks from the moon, what you do? You need a hammer drill. But there is a problem. There is no electricity on the moon. Okay? So you need something that is cordless, and you need something that can stand the radiation from space. So NASA in 1961, thinking already that they want to go to the moon, they contacted Black & Decker. Black & Decker at that time had already some tools, some cordless tools, not too many, and NASA said, look, you're going to create for us a hammer drill that is cordless. And they did. So as humans went to the moon, we collect rocks, we brought back the rocks to the Earth. And Black & Decker used that tool to actually, years later, develop the very tiny vacuum cleaners that we have that are cordless. And at the same time, Black & Decker also developed some cordless medical tools. So that's just an example of technology and having space agencies working together with completely different industries to improve the quality of life here on Earth. I'm going to give you 3 more examples of that, of technology that we use in our day that was developed in the past due to the space exploration and the space missions that happened in the 60s and in the 70s and even later on. One of them is this example of the infrared ear thermometer. It's a non-invasive instrument. And what happened here? So we had a company in 1991 called Diatech Corporation. That company was in contact with NASA JPL, and they said, look, we want to develop an infrared ear thermometer based on a satellite that you guys, NASA, have. And so NASA had a satellite, a space mission, that would look into the planets and the stars. And the planets and the stars, they emit infrared radiation. Why do we care about that? Well, by emitting infrared radiation, we know exactly what's the temperature of that star or that planet. Okay, so that was a space mission. And Diatech Corporation used that in 1991, and they developed that. They developed the infrared ear thermometer that we use today. Example number 2. We all, unfortunately, know about fires here in Portugal, but the same thing in the US, same thing all over the world. And the firefighter gear that the firemen use in the US is actually based in the astronaut suits. Why? Well, think about an astronaut. An astronaut needs to have a suit that is light, right? Because they need to move in space and it has to be light, easy to move. And at the same time, the temperatures in space are very extreme. They have really high radiation, but at the same time it could be really cold. So same thing happens with firefighters. They need to be isolated from really high temperatures, but at the same time they can't be cold. So the American firefighters, they use that. Example number 3. So the software that is used on satellites to do terrestrial remote sensing can now be used on lots of medical imaging, such as CT, X-ray, mammography, etc. So think about a mammography. This is the normal mammography that you get, the scan, and usually doctors wouldn't be able to tell is it cancer or not. And we know how emotional and how difficult that is. And so right now what we do, we use the software that was used on satellites, and basically that software, it kind of gives you a 3D image. It announces the image, giving you 3D. So instead of having the normal scan and mammography, you now have this sort of image. So clearly showing the differences and announcing and telling the doctor immediately if it's cancerous or not. So So those were just a few examples. And this, as I said, that was in the past. Right now we have new challenges. In fact, we have what the United Nations consider to be the 17 new challenges. They are called the Sustainable Development Goals. And all of those goals, we need to address them. They're not solved. And so, what I can tell you is that space exploration can actually address and help solve all those current challenges. Today I'm just going to give you 6 different examples and actually 6 different sustainable development goals and tell you how space exploration can actually help solve all that. So let's start by sustainable development goal that says zero hunger. Obviously we want to solve that. We want to have, particular in developing worlds, we want to have farmers having and getting the most of farming. And how do we do that? How can space exploration help that? Well, satellites. Satellites can produce actually high-resolution images of crops, like this. And then those images will tell you like the farming index. So we will tell the farmers when it's time to water, when it's time to harvest, when it's time to fertilize the soil. So the different times when the farmers can do this or that. And that is extremely important. And that will help in particular developing countries. And for the developed countries already, that will even increase more the production in agriculture. Number 2, example number 2, the sustainable development goal is good health and well-being. And when we say that, we don't want that for just a few people. We want good health and well-being for everybody here in the planet. Even people that live in poor areas or remote areas. But if you think about it, in remote areas, it may take hours or days to reach a hospital. So how is it possible that those people get good health and well-being? Well, we have a kind of similar situation with astronauts that stay for 6 months, a year on the International Space Station. When the astronaut gets sick, you can't simply take an ambulance to go to the International Space Station. So what do? There is a thing called International Space Station Medical Monitoring. What we do is to monitor the astronaut's health before they go to the International Space Station, during and after. And that allows us to create tools to actually see the biological and immunological response of the astronauts. That we can definitely apply to people that live in remote areas or even in areas of poor resources. So again, space exploration helping everybody in the planet. Example number 3. Quality education. Again, we want quality education for everybody, even people in poor areas, even people in remote areas. So let me tell you what space exploration is doing to help that. There is a private company called Spacex. Their ultimate goal is to colonize Mars. But in the meantime, they want to do something different. They want to have a constellation of satellites around the Earth, beaming the internet all over the globe. So there were no areas where the internet wouldn't reach. That's their goal. They're not there yet. They already launched this year 2 of those satellites. They're getting there. Can you imagine the potential of that? So think about remote areas where if the internet would reach, you could have a virtual classroom. You would have the teacher somewhere, and you would have the students in that virtual classroom watching the class. But closer to here and to Portugal, and I would like to give you an example here on Portugal. The OECD wants to improve the digital literacy of youngsters and adults. In Portugal, the digital literacy is only 53%. What is this thing of digital literacy? So think about being able to turn on your computer, or knowing how to access the internet, or even knowing how to create an email or reading your email. For all of us here, I mean, this is a piece of cake, but think about your grandmothers. I'm sure they were not able to check the internet or the email, or they even asked what's that. So that's why in Portugal, we only have 52% of people with digital literacy. The government actually wants in 2030, the Portuguese government wants in 2030 to get that number to up to 80%. And that's a big challenge. And how do we do that? Well, first of all, areas that don't have internet, we need to get the internet there. So again, Spacex is successful. In many years, in a few years, we'll have internet all over the world, and that's a step closer to increasing the digital literacy. One more example. So, example that says sustainable cities and communities. If you think about, the first thing to get a sustainable city is actually to breathe the air. I can tell you I was in a conference beginning of the year. I was in Beijing, in China. And I was sneezing and I was coughing all the time, basically because the quality of the air was really poor. And my colleagues were saying, you know, we've been here before and air was much worse, so you'll get used to it. No, I didn't get used to it, and it's pretty bad. And you can see even here images, so Asia ports here, the quality of the air is not okay. So what can we do? We have satellites, several satellites. I can give you the example, for example, of the European Space Agency. The European Space Agency has a satellite called Sentinel-5. That's the goal is actually, his job is actually to monitor the quality of the air and actually measure certain gases that are poisonous and dangerous. And they can send those reports back to the Earth and to each specific country. And then the countries could say, okay, on Wednesdays and Tuesdays, we are not allowed to take the car, and so everybody has to take public transportation. So it's easier said than done, but it's a possibility. It's the way to actually improve the quality of the air. Number 5, example number 5, responsible production. So it is extremely important not only to have ecological cars and airplanes, but how we produce it is also important. And one of the ways that NASA is doing that is that they're actually improving the quality by producing supersonic passenger airplanes. And that will decrease the noise and it will be much faster on the flights and everything. So the technology is still not there, but we're getting there, and it's a way to actually produce things more responsibly. Example number 6, I'm going to leave you. Climate action. We all know that climate change is a reality, and we know that because we monitor. Again, satellites can come really handy. And what we do with satellites is that they can monitor climate change. And not only that, and more important than that, we know that more and more frequently and more intense, lots of disasters are happening as a result of climate change. And so, not only satellites can actually say, okay, we're monitoring this, we can predict, we can tell people that live in a certain location that something is going to happen, a disaster is going to happen. But if a disaster happens somewhere extremely remote, human aid can't get there immediately. So satellites come really handy because they can immediately see what's happening in that remote location, and people somewhere else can draw a plan and say, we can do this or that, and actually help people that are under the disaster that happened. So those were just 6 examples of things that happen now, that are challenges that we have now, and that the space exploration, the technology that is being developed currently can help. So present challenges, present technology that is being developed now. But how about the future? The future is just around the corner. And in 40 years, 50 years, 100 years time, we'll have new problems, new challenges. At the same time, we'll also have new goals on space exploration. We want to go further than we have ever been before. We want to go to new moons, new planets in our solar system. So for that, there is a cycle that we need to do. We have goals in space exploration. We need to develop technology to help us achieve those goals. And by achieving and by developing new technology, we feed again into new goals, while at the same time developing tools that will help us to develop and to improve the quality of life here on Earth. I can give you 2 examples. So, some studies say that in 50 years' time, more or less, we will run out of minerals here on the Earth. And as you can imagine, if you don't have certain minerals, the production of agriculture will cease. And without agriculture, there's no food, so basically we're in trouble, okay? So what can we do to solve that? Well, there are many ways. One of them, there is a private company called Planetary Resources. They have the goal to mine asteroids. And so their goal is to go to the, you produce satellites, you see which ones are the best asteroids, the better minerals. You go there and you mine, and then you bring back those minerals here. Are they there yet? Do they have the technology to do that? Not even close. But this company, Planetary Resources, is already thinking about that. And that's the important thing. If we have a problem, in 50 years' time, we have to start thinking about the problem and trying to find solutions now. Okay? And then, problem number 2. Think about oil and natural gas reserves here on the Earth. They're not going to finish tomorrow or in the 5 years' time or 10 years' time. But eventually, we will run out of oil and natural gas reserve. So again, there are many solutions to the problem. But there is a very interesting place. There is a moon in our solar system. It's called Titan. It's a moon of Saturn. And it has hundreds of times more oil and natural gases than we have here on the Earth. So in 100 times, 100-year times, or 200 years, if we want to take humans and colonize our solar system, one of the potential locations is this moon, Titan, because it's a nice location, and in addition it has lots of hydrocarbons. So let's start to think about the ways of extracting those hydrocarbons, and it's a potential way also of solving the problems here on Earth regarding that. So above all, we have lots of current and future challenges, and for those we need to find solutions. But to find solutions, we actually need to understand the problem. As Nobel Prize of Physics Richard Feynman says, what I cannot create, I do not understand. So let's use space exploration to actually understand the problems, the challenges we have now and in the future, and in order to produce the technology that will allow us to address those challenges. Because at the end of the day, we're all passengers in this spaceship that we call the Earth. So let us all take this journey together and be passengers, exploring new worlds and trying to find alien life throughout our solar system, while at the same time improving the quality of life here on Earth. Let the journey begin. Thank you.
Super nice, congratulations. So same thing as before, we're going to do like a quick Q&A. So I'll make other questions if you haven't already. I'll shoot the first one. So one of the things that struck me regarding your presentation is this idea that the future right now here on Earth is a little bit in danger, right, for us. Maybe the planet will survive, us we're not really so sure. What's your thought on this whole new thematic of going to Mars and going to other planets and
colonizing,
exactly, and terraforming and all these topics? Like, is this something that we'll be able to see, for example, in my lifetime, so in the next 50 years or something, or do you think it's going to be a little bit further down the road?
We have a joke in our field that says in 30 years we'll be able to colonize Mars. And the joke is it's always 30 years, no matter if we are in 1990 something or 2000 or 3000. So the joke is always 30 years. Because you have the funding agencies wanting to know the time, and 30 years is the next goal. I think the main issue is not if, because we will eventually do it. We will colonize Mars, we will colonize other worlds. I'm not so sure if it's going to be in our lifetime, but eventually. But the main issue here is not going somewhere else and jumping around and destroying the other planets. The issue here is actually addressing the challenges and not running away somewhere else. So we need to address the challenges we have here. Only then, if we're able to address the challenges here, we'll be able to address challenges in other planets and in other moons.
All right. So who has the mic? Right there. All right. So right behind you, there's a gentleman that wants to ask a question. If you could just pass it on, that would be great.
Hello. Thank you very much for the amazing speech.
Thank you.
My question is, how do you think that planetary protection is going to affect all of the planetary resources and Spacex? So how do you think those companies are going to cope with that?
Well, they have to. Every nation in the world is part of this thing called planetary protection, which means that we can't contaminate other planets and other moons with stuff that we take here from the Earth. At the same time, when we have a space mission returning samples to the Earth, everything has to be sterilized, and that's a big, big issue always. So, because we will destroy any organic molecules that are present in comets, etc., etc. Even private agencies and private companies, as you were mentioning, SpaceX, you always have to obey planetary protection no matter what. I think we'll be able to deal with it, and that's why each space agency has planetary protection officers. And they always in contact with the scientists and the engineers and everybody. And I mean, until now it wasn't a problem, to be honest. We just have lots of meetings. I've been to the European Space Agency several times. They're never very happy, the engineers, because the engineers want to do things and that's it, the cheapest way and rapid and quickly as possible. And then people like me say, no, you can't do that because you contaminate the stuff. So they're never happy with that. But they know we all have to work as a team. So maybe it takes a little bit longer and it's more expensive, but yeah, it will happen definitely for sure. And we need to obey planetary protection.
Thank you. All right.
Hello, my name is Diego. I work in digital transformation and digital literacy on a society and transformation level. And I'm also writing a book on nature, technology, and leadership. And my question for you is really how to balance all of this, because you spoke about extraterrestrial life in the beginning and UFOs, and by the Clinton time there was a plan for this, for exploring ETs and to come back with results and everything. The private space funding is still not very big compared to other industries. So how to balance all these dynamics and how to really make sure that we first solve the problems of the Earth, but at the same time we keep evolving and advancing and extracting knowledge from other planets.
Okay, just first of all to clarify, we're not looking for UFOs, the scientific community. We're not even looking for little green men when we have a space mission. So actually what we're doing is we're searching for signatures like our fingerprints. And so, I mean, yes, every space mission has a camera, but the reason is not actually to take photos of potential aliens. So let's clarify that. And there is no secret conspiracy of any government that they discover in Area 50-something or whatever. No. So just to clarify that. In terms of the second part of your question, I think the deal is not to solve first the problems here on Earth. First, it's this cycle I was talking about. You need first to develop the technology, and then with that technology you solve the problems. And it's this cycle, and it's related. It's not something that comes first and then you develop the technology. It's, yes, okay, we have a problem. Can we use some of the technology we have now or not? And then you have to start thinking about new technology. But again, it's always feeding, and again, it's the leading. What is leading is the space exploration. It's always the one leading. Because, again, yes, we have problems now, but in 50 years or 60 years, the problems are going to be different. And if you're only focusing on the problems, You don't develop the technology. You only develop the technology for that small problem. As we're thinking bigger, we're thinking about, okay, we're developing 20 or 30 or 50 or 100 different products. How can we use later those problems to address? So it's that way of thinking to solve the problem.
It's really the multidisciplinary part of it.
Exactly.
All right, okay. Thank you so much. A big round of applause to Zita.